Welcome to the fourth video lecture in our Class 19 series of video lectures. We ended the third one looking at a cartoon depiction of the Wagner-Merwine 1,2 hydride shift. And it was pretty interesting seeing that carbocations can rearrange from less stable to more stable ones. You can also observe 1,2 alkyl shifts, so that'll be a topic that we explore in today's video. So here we have a secondary alcohol, and we're going to treat it with sulfuric acid and methanol. Presumably we're not doing an E1 dehydration, but we're actually going to get methanol to substitute into a carbocation that we create. We could, of course, the first carbocation that we create is the secondary one, and methanol could substitute into that, but that is a minor SN1 type product from this reaction. Another thing that could happen is we could move alkyl groups around in order to obtain a tertiary carbocation. So for example, we could move this methyl group over, and that would give us this tertiary carbocation, which could then be substituted with methanol and deprotonated to give us this methoxy ether. Or, as is drawn here, our ring could expand. Instead of the methyl group taking its electrons and moving over, one of the bonds in our 5-membered ring could go ahead and take its electrons and form a bond to the carbocation. If that happened, we would generate a 6-membered ring. So you need to be careful to count carbons. I'm probably not going to give you all sorts of carbocation rearrangement questions. These were things I was tortured with in graduate school. But it's important that you know that you can, rearrange carbocations and move hydrides around and also alkyl groups. Interesting things happen when you generate carbocations. And of course, if we've expanded our ring, then methanol can substitute into our tertiary carbocation. We can get this methoxy ether. Recall that primary carbocations are not formed for the purposes of our class. When we get into the second semester, we do see certain types of substrates can generate primary carbocations, but we haven't talked about those necessarily yet in depth and in detail. Methyl groups can migrate in a concerted fashion. So here we've got neopentyl alcohol. We treat it with HBr. We can't really do an SN2 onto our primary carbon because there's so much beta branching that really shuts the SN2 reaction down. But once we've protonated that hydroxyl group, we can kick it out in a concerted fashion using one of these alkyl migrations, right? One of these methyl groups migrating over to that primary carbon center to generate a tertiary carbocation. And then our bromide anion will substitute in. So I used to actually put this type of question on the final exam, I believe, just as an example of a carbocation rearrangement. Hard to tell what I'm going to do this year. Anyways, how does one make alkyl bromides? Well, if we've got a primary alcohol like propanol and we treat it with HBr, we're going to be making 1-bromopropane, and this will be through an SN2-like reaction. If we treat tert-butyl alcohol with HBr, we'll protonate the hydroxyl group and it will leave as water, forming a tertiary carbocation, which then gets substituted by bromide. And here we've got 2-bromo-2-methylpropane. This is through an SN1 mechanism. Secondary carbons are more difficult. So here we have isopropyl alcohol. It would be difficult to treat it with HBr and substitute that carbon with bromine through either a SN2 or a SN1 mechanism. So what we do is we treat these secondary alcohols with phosphorus tribromide, and this actually goes through an SN2-like mechanism, but it's helped along by having this phosphorus sort of tug our hydroxyl group out with the bromide attacking it. So here's a mechanism. We've got a lone pair on oxygen. Phosphorus is an oxophile. It likes to burn or be oxidized by oxygen. We kick a bromide anion out, and then that bromide anion comes back in, hits our carbon through an SN2-like mechanism, kicking out PBr2OH. So I think I'll go ahead and end this video here, and we'll look at alkyl chlorides in our 5th and last lecture video for this Class 19 series. Good luck with the question for this one.